At the end of the episode, we see this strong window. So it's just this window where Picard's hanging out, looking out the outside. And so I thought about this because I do some vacuum stuff. Oh, here he is, pensive, thinking. Maybe I'll think better if I look outside, which, actually is psychologically right. Yeah, look outside, look outside.
Yeah.
So here's this window. So my question was, how strong is this window? That's a big window. Or on the outside is the vacuum of space.
Okay.
So to calculate this, let's calculate it. So the pressure of the vacuum of space is extremely low, far less than that on Earth, ranging roughly for 10 to the minus 4, to less than 10 to the minus 15 pascals. I'm going to choose this one. This unit's pascals. Pressure comparison, Earth at sea level, 1 atmosphere. So that's 101,325 kPa.
Okay. Wait, not kPa.
Whoop, my bad. 101,325 pascals.
There we go. Yeah.
These two numbers. Yeah, good catch. Thank you. Okay, so then, and to estimate the size of this window, I said Jean-Luc Picard, he's 1.78 meters.
Okay.
I'll use that number because the window, like we miss his shoes and his feet somewhere there maybe.
Yeah.
And then also about the same gap on the top. So if he were to like step on the ledge, he might feel that window quite nicely. Close enough. I'll use that number. So here it is. The net force on that window is equal to the difference in the pressure from the inside versus the outside times the area of that window.
Yep.
And so that's pressure inside minus pressure outside times the width of the window times the height of the window. And for 101,325 PA versus 3 times 10 to the minus 15, like this is effectively 0. I'm just going to ignore
I agree. Just
ignore that. Don't worry about it. Here's these two numbers, and that's 90.2 kilonewtons.
Jeez.
Actually, I don't think in newtons. Like I don't know how hard is a newton, but I do know what a kilogram, like what it feels like. And so I divided by gravity, 9.81 times 10 to the meter, 9.81 meters per second squared. So this force of this window that this window is like holding up. It's proportional. It's about 92,000 kilograms.
Okay.
9,200 kilograms.
Okay.
Okay. I've never lifted anything that big. Like what is that? So I looked up.
Oh,
some
you haven't?
comparisons.
I have.
Okay. Yeah. It was your feelings. It was 92,000. 92.
Yeah.
Okay.
I'm just
okay.
strong.
Heavy feelings. Okay. So so I looked up some comparisons, and that's like 2 adult male African elephants. Like 2 of these elephants. You've lifted these? Yeah, that's what you're saying. There's 2 of these
overhead press.
Elephants. Just shoulders, no cheating, no push press, just squeeze the glutes, just the shoulders.
Not a problem.
Not a problem. In fact, you just lifted 6 cars over your head. That's the force, that's the weight on this window. That's incredible. That's incredible, like engineering. Yeah, right? Like future. Hey, cool engineering. Super strong. 2 elephants.
I guess
2 elephants on this window. Damn.
Now, to be fair, it's not feet of the elephants on the window. It is distributed everywhere equally on that window, which helps.
Is this 8 elephant feet wide? Right? 8 elephant feet.
That actually might be true. Yeah, that might actually be the size of 8 elephant feet.
I mean, I'm not an elephant foot specialist, but like I think that's kind of close.
You might be right. Yeah. Either way, it's super strong.
I mean, actually, okay, wait. If you were to have a person lay down and an elephant step on them, I think 1 elephant's worth of foot might cover the whole thing. Right? I mean, it's been a while since I've touched an elephant's foot. I'm not an elephant foot specialist, but like, right? But it would be like 2 elephants standing on top of each other on this window.
Yeah.
Holy cow!
It's a lot of weight on that window.
Weight on the window. Strong as it?
I say force, but it's not weight.
Yeah, I get you. Yeah, force is type of weight.
Okay, in the International Space Station today, we have windows.
That's right.
Yeah.
But I think they're smaller, right? Yeah. So it scales with the area. So if you have the windows are small enough, then you can get within the engineering limitations of whatever those windows are made out of. Yeah. But I don't think we have one of these like big old windows.
Maybe there's some specialized glass out there that can handle it. Glass is complicated and it can withstand a lot actually. but I don't know the state of the art. But it is Star
don't
Trek,
either.
and they. Oh yeah, I mean it's actually pretty big. It does have the metal components in between the windows, but still, actually this is bigger than I was
Also,
expecting.
this is like a super. If I remember from this photograph, it's like a very wide angle lens. These might be smaller than we think.
But okay, looking at this one with Tracy Caldwell Dyson in the thing.
Yep, Tracy Caldwell does.
I mean, that's a pretty big. Those are pretty big windows, actually. Bigger. Bigger than I was expecting.
Or she is
like
small
that's-
human. No, actually, I don't know how tall she is.
I mean, okay, like the diameter of that circle is her hip to shoulders.
Circle.
That's
Shoulders. Yeah. Okay.
that's maybe that could even be like an elephant on that window. Maybe,
I don't know.
but it's a lot. It's
a lot.
surprisingly large.
Surprisingly large
Actually.
window.
I'm surprised that glass technology exists. I don't know the state of the art of glass.
I don't even know if it is glass. Yeah.
Oh, it could be like some plastic something.
Steel. Trans steel. Oh boy, no.
Nope, that's Star Wars.
That's what I was looking for. Okay. Anyway, the idea is a lot of force, super good engineering in the future coming up. I'm excited for it.
Yeah, and also Star Trek has those like force fields that hold the air back. Maybe if this is glass, maybe it also has some additional help.
That's right, but I gotta believe no, they don't do that, right? Because if you ever lose power to your systems, all the force fields go down. It's like pop
That's
immediately.
right, that would suck. Yeah, that's okay in the shuttle bay, where it's there's traffic. But here, this is a permanent fixture. Good point.
You ever power down, just your ship's a pop.
Yeah.